Okay, so if you remember back from Math 1 long ago, an identity is just like what would you multiply a number times to get that number back? Or the additive identity, what do you add to a number so that it doesn't change it? So the multiplicative identity is 1, right? Anything times 1, you just get it back. The additive identity is 0. Now with matrices, if I have a 1, 2, 3, 4, a 2 by 2 matrix, and I want to add a matrix so that I get the same 1, 2, 3, 4 back, I can't add 0 because there's no such thing. You can't add a non-matrix with a matrix. But the additive identity is zeros. It just depends on what size the matrix is. So if it's a 2 by 2, I just have to have all zeros in a 2 by 2. So like if I asked on a quiz, what is the additive identity of a 3 by 2 matrix? Then you'd have to have the same size, 3 by 2. Oh, no, I'm going the wrong way. 3 by 2 with all zeros. So when you add it, you wouldn't change it. But since multiplication is weird and we do row times column, the multiplicative identity first, if you're going to multiply a 2 by 2 and end up with another 2 by 2, then you have to multiply it by a 2 by 2. So like if you have a 3 by 2 and you want to multiply it by another matrix so that you get a 3 by 2, you'd have to multiply it by a 2 match and another 2. So you have to be careful. Like there's no 3 by 2 identity. It has to be multiplied by 2 by 2. But we'll look at that later. So if you have 3, 5, 4, 6, and you want to get 3, 5, 4, 6, I can't just do all ones in here. Because remember, you're doing the row times the column, first row times first column, and you want that to equal 3. So if I put both ones right here, then I would end up doing 3 plus 5 and get 8. And that's not what you want. You just want the 3. You don't want the 5. So you do a 1 and a 0. 3 times 1 plus 5 times 0, that gives you the 3. Would that also give us the 4? Well, if I do the second row times that column, 4 times 1 is 4, 6 times 0 is 6, and you'd get the 4. So that works. So in the second column, you want the 3 and the 5 to give you that 5. So this time you don't want the 3, but you want the 5. So you do the 0 and the 1. And that way 3 times 0 and 5 times 1 is 5. To get the 6, 4 times 0, 6 times 1 will give you the 6. So that's called your identity matrix. And it's 1, 0, 0, 1. When you multiply it by 2 by 1, you get back or 2 by 2, you get back. Now, if I have, say, let's do a quick, actually, excuse me. So if I had a 3 by 2, 1, 2, 3, 4, 5, 6, and I multiplied it by, since that's a 3 by 2, I'd have to do just a, 1, 0, 0, 1. will that give us back the same thing? So yeah, first row times the first column would be 1 and then 0, so that's 1. First row, second column be 0 and 2, so 2. And then again, next row with the first column would be 3. 3, 0, 4, 1 is 4. So yeah, 5 and 6. So if I want an identity, it always doesn't matter if I have a 3 by 2, then the identity has to be a square. It's always square, and it has to match that one. So that's a 2 by 2 identity. A 3 by 3 identity is going to work the same way. You have that 3 by 3 and you want to multiply it, then the identity for this first row, first column, you'd want the 1, not the 2, not the -4. And then for the second row, or the first row, second column, you'd only want the 2. Then for the last one, you'd only want the -4. Excuse me again. I think every time I record, I get coughs. Okay. So as you can see, it's this diagonal of ones that makes an identity. So if you wanted a 4 by 4 identity, it'd just be 4 ones and the rest zeros. So that's an identity. Now we're going to use these later. For right now, I just wanted to show you that. But this is a determinant. And a determinant is one single number. And when you want the determinant, like if this is matrix A, I could ask for, and it looks like absolute value, but it means determinant. So I could say, what's the determinant of A? Or I could say, what's the determinant of A? Or I could even take and put straight up and down lines around. So instead of the matrix little brackets, if you do the straight up and down lines, that's called the determinant. And the determinant for a 2 by 2 is really simple. When you find the determinant, you cross multiply. So you're going to multiply the 3 and the 8, 24, and then you're going to subtract going from the bottom up. So 5 times 2, which is 10. So the determinant of this matrix, and determinant's always going to be just a number. And we use this determinant for different things, and you're going to see that when we start getting to matrix. But right now, it's just finding the determinant. So multiply minus multiply. That easy. The determinant of a 3 by 3 is really, it's much more difficult just because you have to multiply so much. And what I tell people to do is take the first row and write it again, 3, 1, -3. And then the next one, -4, -5, 2. And that way you have to multiply those 3. So -15 times 4 is -60. And you're going to add that to these 3. -4 is 0 and -3. So it's this diagonal starting with 3, then starting with the -4, that would be 0. And then starting with the 2. 2, 1, and 2 is 4. And then you're going to subtract, and again, it's the sum of the 3 going up. So starting with the -3, -3, -5, and 2, 15 times 2 is 30. 2, 0, 3 is 0. 4, 1, -4 is a -16. And then you add this group, minus, add that group, 30 and -16 is 14. And then combine those two. So that's -70 for that determinant. Totally a pain. So excuse me. So let's go back here. And so Desmos, I already showed you on the graph on the matrix calculator. We'll come back to this matrix calculator. And let's make that 2 by 2. I showed you the first one. So not that. New matrix, 2 by 2, and it was, hold on, I gotta go back and change that page. Three, 2, 5, 8. So it was 3, 2, 5, 8. So right there, if you want the determinant of matrix A, that was 14, just like I said, when you multiply and subtract. So 2 by 2s are pretty easy to do, just quick in your head, but if you need the calculator, it will do the determinant for you. So that 3 by 3, which was 3, -4, 2, 3, -4, 2, and 1, -5, 0, 1, -5, 0, and -3, 2, 4, 4. I can find the determinant of B, -70. So there will be, and I'll show you some problems. I won't ever make you do the determinant of a 3 by 3 by hand, but there will be ones where you have to understand the determinant of a 2 by 2. Like if I put a variable in there and told you what the determinant is, I'll show you that later. But for right now, just use your calculator to get the determinants. The other thing is called the inverse. So inverses, and this is going to be multiplicative inverse. Like if I have 5 times some number, if I get the identity back, because the identity is 1 in multiplication, then the inverse is what can you multiply a number by to get the, and the answer is 1/5, the reciprocal. That's the inverse. If I did 2/3, what do you multiply by 2/3 by to equal 1? 3/2, right? Called the multiplicative inverse. So in matrices, it's what can I multiply this matrix times so that it equals 1, 0, 0, 1. Now figuring that out is not easy. So 7, 2, -3, 4. We're going to go over to Desmos. Were you guys, hold on a minute. Was I sharing this when I said all that stuff? Sorry about that. So let me show you that again, just in case I was not on the right share. So when you multiply and it equals the identity, that's called the inverse. So the inverse of just a regular number is its reciprocal. The inverse of a matrix is what you'd multiply to get the identity type matrix. So I'm going to clear those old ones. So if I make a new matrix, a 2 by 2, and that matrix was 7, 2, -3, 4, 7, 2, -3, 4, then this to the -1 power is the inverse. So you would say, what is A to the -1? Ugly decimals, so let's make it a fraction. All right, so the inverse is actually, so that's the inverse matrix. So like I said, if you do A times the inverse of A, you would get the identity always. Anytime you multiply an inverse, only square matrices have inverses. But that determinant is part of these fractions, and there's a reason for that. So if I find the determinant of A, you'll see it's 34, and you see the 34s in there? So if I do the inverse of A, and then take that matrix, or sorry, if I do the inverse of A and multiply it by its determinant, you'll see you get whole numbers back. And that's always going to work because we're going to look at the determinants. Let me write this out for you. So it was 34. So when you find the determinant of a matrix of a 2 by 2, or when you find the inverse, it's going to be 1 over the determinant. So that's 34. And then these two numbers ended up switching, 4 and 7. And then these two numbers ended up being the opposite. But you can see that on Desmos when you multiply out that 34. Just remember you're writing it as a fraction. So if I'm going to find the inverse of this matrix, it's going to be 1 over whatever the determinant is. And then this doesn't work the same way. It's not switching around stuff. So let me show you on Desmos. So if my second matrix is a 3 by 3, -2, 3, -4, -2, 3, 5, 1, 4, 5, 1, 4, 3, -2, -1, 3, -2, 1. So I want the determinant of that matrix. So it's 89. And then the inverse, so b to the -1 power, change it to fractions, and multiply it by 89. So it will be, you can see all your numbers now. So like I said, it's 1 over the determinant, so it'll be 1 over 89, and then put in all of your numbers. I'm looking at Desmos, it's 7, 11, 16, 7, 11, 16, 17, 14, -12, 17, 14, -12. You guys don't see me flipping back and forth with Desmos, but -13, 5, -17, -13, 5, -17. So it's not these numbers just rewritten like it is with a 2 by 2. But that's it. So it's always 1 over the determinant. So you need it first, and then the numeric part. Questions on that inverse? All Desmos work. Okay, so the last part, transposing a matrix, is just if this is a 2 by 3, to transpose it, if this is A, you might see that it says A to the T power. And you can do the T power on Desmos, but you don't need to, because all transposing is taking whatever the first row is and make that your first column. So the 5, -8, 2 becomes 5, -8, 2 going down. Then the next row becomes your next column, -6, 7, 3. That's called transposing the matrix, just switching the rows for the columns. Yeah, so if it says find m to the t power, that means transpose that matrix. So a 3 by 3 would still be a 3 by 3. It's just now 5, 8, -3 is your first row. And then 6, -2, -1, that becomes your next row. 4, 3, 7. So if you're doing more operations with the transpose, then you could do that in Desmos, but like here, if you wanted to transpose that B matrix, you do B to the T power, and that transposes it. But if that's all you're doing, it's easier just to write it. But if you were doing that with some multiplication or other stuff, then you can transpose it in here. All right, so back to here, your assignment has 2 by 2 matrix, find the determinant and the inverse of each. So write the determinant out to the side and then write it as the inverse as 1 over the determinant. And there are some 3 by 3s, same thing, just 4 of them. Find the determinant and the inverse. Make sure you're changing those to fractions or multiply out that fractions. And then the last ones are just transpose each one of those matrices. So not too bad, probably be done before 11:30. Any questions? All right, make sure you get that matrix quiz done, check your grades, make sure you're all up to date and happy with where you stand. Let me know if I can help you with anything. Other than that, have a great Tuesday, and I shall see you tomorrow.
Have a good day.
You too.
Have
Thanks.
a good day.
You too. Bye.